Hey guys, so this is our very first Math 2 lesson from the book. So on your book, you should be pulling out pages, or you could keep them in your book too. Pages 3 through the last page is 6, 3 through 6. So it's a short lesson on exponent rules. Okay, you're gonna need different colored pens, highlighters. I like to use highlighters. I color code things. I like to keep things different color, make it fun. Yeah, okay. If you don't have your book yet, you need to go to the school and grab your book. If not, just in case, I did attach the PDF of this file in case you need to print it. So that is there as well. Okay. All right. So let me get this situated. All right. So in class, this would be our very first lesson. So I would go over what we do. We always do something called unpacking the learning targets. And that means to circle the verb and underline what we're doing. So we are going to develop basic exponent properties. We're going to simplify expressions involving exponents. Okay, so we're going to develop our basic properties for exponents, and we're going to simplify problems with exponents. Okay, so we have this very first problem. It says an iceberg is a large piece of freshwater ice that has broken off from a glacier or ice shelf and is floating in open seawater. Icebergs are classified by size and shape. The smallest sized iceberg is called a growler. I wonder if that's because it makes growling noises when it's in the ocean. I don't know. A growler was found floating in the ocean just off the shore of Greenland. Its volume above water was approximately 27 cubic meters. Okay, that's actually really big. Okay, and that's some information about this. It's something mathematical, so I want to kind of squiggly underline that. It seems like we might be using that later on. Okay, over on the right, there's some academic vocabulary. It goes over what a growler is. It's a fragment of ice, so a piece of the ice, about the size of a small truck. Growlers extend less than 3 feet above the sea surface and have a top area of about 215 square feet. Growlers got their name from the sound they make when they melt, similar to a growling animal. Oh, so when they melt, they make a growling sound. That's pretty cool. Okay. All right. So it says number 1, 2 icebergs float near this growler. One iceberg's volume is 3 to the 4th times greater than the growler. The second iceberg's volume is 2 to the 8th times greater than the growler. Which iceberg has a larger volume? Explain. So normally in class, I would have you guys discuss this and we would talk about what we know. And so we know that the first iceberg is, what did it say? 3 to the 4th times greater than the growler. Well, what is 3 to the 4th? Well, that is just 3 times itself 4 times. And if we group this, 3 times 3 is 9, and another 3 times 3 is 9, and 9 times 9 is 81. Okay. So we would multiply the original growler's volume by 80, or 1. Okay. The other iceberg, it said it was 2 to the 8th times greater than the growler. So let's figure out what 2 to the 8th is. That means 2 times itself 8 times. So 2 times 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 2. Well, we know 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. And then 128 times 2 is 256. Sorry, it was a bit early there. I was like, can I do math in my head? So we look at how much we're multiplying by. We would multiply the original growler by 81 to see how big the volume was, and then the original growler by 256 to see how much bigger the second iceberg was. Well, obviously the second iceberg is going to be much larger, so the answer to this one is iceberg number 2. is larger. Okay. And I'm going to go ahead and also box that because that's the answer to the question. Oops, I went over my exclamation mark. But so our math is kind of doing the explaining here, and then we have our answer to back it up. Okay. Number 2, what is the meaning of 3 to the 4th and 2 to the 8th? Why do you think exponents are used when writing numbers? Well, and I would have you guys tell me your thoughts on that, but since I'm literally talking to myself, we'll have to just pretend. So why do we use exponents to write numbers like this? Well, 3 to the 4th obviously is a big number, 81. 2 to the 8th, even bigger, is 256. But isn't it so much simpler to write it using exponents instead of to write it as their actual numbers? That's why mathematicians do that. That's why scientists do that, because scientists are the ones that mostly use exponential things, like writing things simpler, because they'll deal with super small numbers and super duper big numbers, and it's just way easier to write in this format. So it's just easier to write. Suppose the original growler's volume under the water is 9 times the volume above. How much of its ice is below the surface? Okay, well, it's saying that the original growler's volume under the water is 9 times the volume above. Well, the volume above is 27 cubic meters. Let's multiply that by 9 because it's 9 times as big as the volume. So 27 times 9. If I pull out, where's my nice calculator? Here we go. The calculator I want you guys to get is one of these if you could. They're like 10 bucks at Target. Or you can get one from the 99-cent store. Those work too. They're like 3 bucks. 243. So 243 meters cubed. Okay, so this is how much of the volume is below the surface of the water. So underwater is a 243 cubic meters of ice of this growler. Okay. All right, it says to write your solutions to item 3 using powers. Okay, that's different. So it says write the missing term as a power of 3. So we have the volume above the water times 3 to the second equals the volume below the surface. Well, the volume above the water was 27. So how can we write that as an exponent? Well, let's see. Let's do a little factor tree. 27. Well, since we're using 3's, is 27 divisible by 3? I think it is. Actually, I know it is. 3 times 9, and we can break down the 9 to 3 times 3. So 27 is the same as 3 to the 3rd. So 3 to the 3rd times, remember it was times 9, and 9 is written as 3 times 3, so 3 squared, equals, now they want us to write this still as an exponent, so we have 3 to the 3rd times 3 squared. Well, we know it needs to equal 243, ends up being 2 to the 5th. Whenever you multiply exponents, you add multiply like bases, you add their exponents. And let's check to see, that should be a 3, not a 2. Let's check to see that 3 to the 5th is 243. So you can multiply out 3 times 3 times 3 times 3 times 3, 5 times. Oops, not a plus. 4 and 5. You could do it this way and hit equals, and we get 243. Or you could hit 3, and what's nice about this scientific calculator is that little up arrow button where my finger's on, and I can raise it to the 5th power, and I get 243. So that checks out, okay? All right, now it says, look at the equation you completed for item 4. What relationship do you notice between the exponents on the left of the equation and the exponents on the right? And that's pretty much exactly what I just said. And basically, the powers on the left add up to the power on the right. These powers, the power of 3 and the power of 2, when you add them, it adds up to 5. So the powers on the left add up to the power on the right. Now, when you guys take notes, you should be keeping these in a 3-ring binder or folder in order as best you can, because you want to go back to these notes whenever you can. All right. They will be good, solid notes, good references for you guys. It'll be easier to find things than trying to search up things on the internet, because if you don't know exactly what you're searching for, you're not going to find it. All right. So next page, we are on number 6. It says to use the table below to help verify the pattern that you noticed in item 5. First, write each product in the table in expanded form. Then express the product as a single power of the given base. The first one has been done for you. So let's see what they did here. We have the original product is 2 to the 2nd times 2 to the 4th. And they wrote out 1, 2, 3, 4, 5, 6 fours. But that's because when you add the powers 2 and 4, you get 6. And so that means there's 6 2s that you're multiplying together. Okay, I see what they want us to do. So for the 5 to the 3rd times 5 squared, that means that we're going to need to write 5 to the 3rd. So that's 3 5s multiplied together. And then 5 to the 2nd. So that's 2 5s multiplied together for a total of 5 5s. So 5 to the 5th. Okay, so the next one, we have x to the 4th and x to the 7th. So I would write out 4 x's and then 7 x's and then write the total. So I'm going to skip these two expanded form ones because I think we have it for now. So this will be x to what power? Well, 7 plus 4 is 11. So x to the 11th. And then what will be this last one? A to the 6th times a squared. That'll be a to the 8th. Because 6 plus 2 is 8. Okay, so number 7, it says, based on the pattern you observed in the table in item 6, write the missing exponent in the box below to complete the product of powers property for exponents. All right, so we're coming up on a property. So I'm going to use my highlighter to highlight that so it sticks out at me when I'm looking at these notes and I can refer back to it. Okay, and let's see. Okay. So it says a to the m times a to the n equals, well, we know when we are multiplying like bases, what do we do with those exponents? That's right, we add them. So that should be a to the m plus n. Okay, and I'm going to highlight that also. The ink smudged a little bit, but that's okay. And a common name for this property, I know it says product of powers property up here, but when I learned it as being called product rule. So that's what I'm going to call it. So you're going to hear me use the name product rule on stuff like that. Okay, because that's how I learned it. So of course that's going to be how I teach it, because that's what makes sense to me. Oops. All right, use the product of powers property to write x to the 3/4 power times x to the 5/4 power. So just because it's a fraction doesn't mean anything is done differently. So we have x to the 3/4 times x to the 5/4. Remember, we're using product rule, so that means we're adding the exponents because we're multiplying like bases. So that's the same as having x to the 3/4 plus 5/4. And since they have common denominators, I can add these fractions. 3/4 plus 5/4 is 8/4. And 8 is divisible by 4. 8 divided by 4 is 2. So this simplifies down to x squared. Easy peasy lemon squeezy. All right, number 9, it says the density of an iceberg is determined by dividing its mass by its volume. Dividing its mass by its volume. If you look over to the left, under Connect to Science, it says the formula for density is D equals M over V. Density equals mass over volume. So that's kind of an important little formula because we're going to be using that. So I'm going to highlight it in a different color and put little stars next to it so it sticks out in my notes. Okay. All right, so going back to the problem, it says suppose a growler had a mass, so M, mass of 59,049 kilograms and a volume of 81 cubic meters. So we have a mass of 59,049 and we have a volume of 81 cubic meters. Compute the density of this iceberg. Okay, well then, if we use that formula, density equals mass over volume, then we can go like this. The mass is 59,049 kilograms. I'll put the units on there also. And the volume is 81 cubic meters, so 81 meters cubed. Okay, so let's go ahead and just divide those. So 59,049 divided by 81 is 729. So that means that this is 729 kilograms per meters cubed. So you write that as kilograms over meters cubed. Anytime you're dealing with a word problem that has the units in there, you have to include the units in your answer. Okay, so what does that mean as exponents? It says in number 10 to write your solution in item 9 using powers of 9. Powers of 9. So that means that the base, because it's all about the base, is 9. So let's change the mass. The mass was 59,049. So I'm going to go over here on this little scratch paper side. It's already telling me that I need to divide by 9. So I'm going to start by doing that. 59,049 divided by 9. And I get 6,561. And I'm just going to, it's powers of 9, so I'm going to divide by 9 again. Divide by 9. And I get 729. Ooh, that sounds familiar. And powers of 9, so divide by 9 again. Divide by 9. I get 81. Oh, now I don't even need my calculator because 81 is 9 times 9. So this is 1, 2, 3, 4, 5 nines. So that means that the mass is 9 to the 5th. The volume was 81. That's super easy. 81 is just 2 nines. So it's 9 to the 2nd power. Equals 729 was up here. So if I just look at what's below the 729, I have 3 nines, 9 to the 3rd power. And just to double check that, we can raise 9 to the 3rd power and see what we get. And we get 729. So equals 9 to the 3rd. So what happened here? When we're dividing like bases, what happens to the exponents? How did we get a 3 from a 9 to the 5th and a 9 squared? Hopefully you saw that we are subtracting the exponents. Okay, so the exponents, because it says to describe the pattern, on the left, and by left I mean left of the equal sign, on the left, subtract and equal the exponent on the right. Okay, so that's going to lead us to another property. So go ahead and turn that page. If I can grab it, here we go. We're on page 5 now. They want us to do a table just like we did for the product rule. It says use the table to help verify the pattern that we noticed in number 11. First, write each quotient in the table below in expanded form, then express the quotient as a single power of the given base. The first one has been done for you. So we have 2 to the 5th over 2 squared. So we have 2 to the 5th, so 5 2's over 2 squared, so 2 2's. And look what they did. They started canceling stuff out. They are like, okay, we have a set of 2's in common numerator and denominator. And again, numerator and the denominator. So now the denominator is completely canceled out. All I have left are 3 2's in the numerator. So that is 2 to the 3rd. And guess what? 5 minus 2 is 3. So 2 to the 3rd. Let's try the next one. So the next one is 5 to the 8th over 5 to the 6th. So I need 8 5s in the numerator. 1, 2, 3, 4, 5, 6, 7, 8 over 6 5s in the denominator. 1, 2, 3, 4, 5, 6. And let's start canceling stuff out. So we have a pair of 2's top and bottom, another pair top and bottom, another pair top and bottom, another pair, another pair, another pair. And all I have left in the numerator are 2 5s. So that means that I have 5 to the 2nd. Well, and guess what? 8 minus 6 is 2. So again, 5 to the 2nd. Let's try the next one. A to the 3rd over A to the 1st. So we have 3 A's multiplying in the numerator and just 1 in the denominator. Okay, well, we only have 1 in common, top and bottom, that can cancel. So that leaves us with just A squared, because there's only 2 A's left. A times A is A squared. And 3 minus 1 is 2. All right, for this last one, we have x to the 7th, so I need 7 x's. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. All over, there's 3 x's in the denominator. Okay. All right, and let's start canceling. So we have a pair top and bottom, another pair top and bottom, another pair top and bottom. Now I'm out. So all I have left are 4 x's in the numerator. So that is just x to the 4th. And guess what? 7 minus 3 is 4. So we really are subtracting exponents there from top to bottom, always top to bottom, left, right. All right, based on the pattern we observed in item 12, write the missing exponent in the box below to complete the quotient of powers property. So there is another property. Quotient in math means division, and we are dividing exponents there. So we have a to the m over a to the n equals a to the, well, we are subtracting, so that would be to the m minus n, where a cannot equal 0. The reason why a cannot equal 0 is because if we have an a equals 0, like for instance in the denominator, that means we get a 0 in the denominator, and that's never, ever, ever allowed because, where's my calculator? Let me show you what happens when we have something in the denominator. Let's say I divide 5 divided by 0. Divide by 0 error. You get an error. Your calculator freaks out on you. So we can never, ever, ever have 0 in the denominator. So even our base cannot be 0. Okay? All righty then. So we have our quotient property there, and I would call that the quotient rule. That's how I learned it, so I'm going to name it that. Quotient rule. This is what I grew up calling it because that's how it was taught to me. And I'm going to highlight this. Okay. All right, so number 14, it says to use the quotient of powers property to write a to the 4th over a squared. Does it say a to the 4th? Let me make sure. Oh, no, that doesn't. Sorry. I need to zoom in. Those are fractions. There we go. A to the 11/3 over a to the 2/3 as a single power. Okay, so just like the product rule one that we did. So remember, we are dividing like bases. The bases are the a's. So that means that we are subtracting. We're using the quotient rule. So that means I'm going to have a to the 11/3 minus 2/3 because I'm subtracting their exponents. And luckily, they made it nice and easy for us because I have common denominators and I can go ahead and subtract those fractions. So 11/3 minus 2/3 is 9/3. So I have a to the 9/3 power, but 9 is divisible by 3. So I can keep simplifying that. 9 divided by 3 is 3. So this is really a to the 3rd power. And we just use the quotient rule. All right. So I have an example here. It says the product and quotient properties of exponents can be used to simplify expressions. So I'm going to go ahead and do example A over to the right here because I just want to explain it. So we need to simplify 2x to the 5th times 5x to the 4th. Now, what the book shows in this example is they show grouping the numbers and the letters together. So they'll put the numbers together and then they'll put the letters together. I just want you guys to be in the habit of just doing that in your heads pretty much. We're multiplying, so we can always multiply, right? These are like terms, so we can multiply them. So 2 times 5 is 10. And then x to the 5th times x to the 4th. We're multiplying like basis, so we're using the product rule. So that means that we add those exponents. So that would be x to the 5 plus 4, which is 9. So there's really not a lot of work to show for that type of problem. I know the book broke it down and how do you group the terms together. See how they grouped the 2 and the 5 and then the x's together and then they did all that. I am not expecting you guys to show that kind of work. You don't have to. You could just go straight to the answer, okay, on these ones. Basically, however I show you how to do a problem, that's the type of work I need to see you show. Capiche? Good. Example B. All right, so for this one, it says to simplify 2x to the 5th, y to the 4th over xy squared. And I'm also going to do this one over to the right, or actually to the left, because that's where the scratch paper is. So example B. And we're going to simplify 2x to the 5th, y to the 4th over xy squared. Now, when we're dividing, I tell my students we can get a little cancel happy, and that's okay. Just don't go overboard, because sometimes we get super cancel happy, and then everything goes away, and we're like, what just happened? And we don't want to get to that point. So here's what I tell my students. The only number we have is the 2. In the denominator, there's no number, so that means it's just a 1. But 2 divided by 1 is 2, so I don't even need to worry about that. So I know my answer is going to have a 2 in it. Okay? Look at the x's. I have an x to the 5th over an x. There's no exponent on that x. So that means we assume it to be a 1. Okay? Now, I know we are dividing and we are using quotient rule, but I actually like doing this better. We can cancel out this x because there's only one of them. And we could take away 1 from the total up top. So now there's x to the 4th. And then we're done with the x's. So bring it down. X to the 4th is left. For the y's, I have y to the 4th over y squared. Well, I can cancel out these y squareds. There's 2 y's there. I could take away 2 up here. I'm still subtracting. I'm just using this cancellation method. And showing what I canceled, that's the work that I'm showing. And then this is the answer, 2x to the 4th y squared. Okay. So here I have try these A through B. So this is where I'm going to stop. And you guys are going to answer these on the Ed Puzzles. This is 2813. I'm going to write that down. Okay. And you're going to answer these. So letter A should be, let's see, I have a 4 times a negative 2. 4 times negative 2 is negative 8. And then I also have, let me zoom in a little bit, x, there's no exponents. So that means it's an x to the 1st power times an x squared. Well, x to the 1st times x squared, you add the exponents. 1 plus 2 is 3, so that's x to the 3rd. And then y to the 4th times y to the 5th. Well, 4 plus 5 is 9, so that's y to the 9th. And there's that one. Okay. Letter B, we have 2 over 4. So 2 goes into itself once, goes into 4 twice. So I know I'm going to have a 1/2. But I'm just going to leave that there for now. For the a's, I have a squared over a. There's no exponents. So that means it's to the 1st power. And that a will cancel with one of them up there. So that leaves me with just an a to the 1st power in the numerator. So I have an a in the numerator. I don't need to write the 1 because we'll assume that there's a 1 in front of that a anyway. And then b to the 5th over b squared. Well, I can cancel out those 2 b's in the denominator. And 5 minus 2 leaves me with 3 in the numerator. So I have a b to the 3rd left in the numerator. And I have a c over c. Well, c divided by c is just a 1. So those completely cancel. And all I have in the denominator is that 2 that we reduced. And so we have ab to the 3rd all over 2. You could even write this as 1/2 AB cubed, and that would mean the same thing. But I like this one better. All right, letter C. 6y to the 3rd over 18x times 2xy. If it helps you visually, you could put that 2xy over 1 and make it a fraction. Okay, and we can go ahead and multiply out the numerator across. So 6y to the 3rd times 2xy. Well, 6 times 2 is 12. And the x is the only x. You always put the letters in alphabetical order. Okay, and then y to the 3rd times y to the 1st. 3 plus 1 is 4, so that would be y to the 4th. All over 18x times 1 is just 18x. And then from there, we can cancel out. I already see these x's completely cancel. And 12 over 18, they're both even numbers, so those will be reducible. Let's see, 6 goes into 12 2 times, and 6 goes into 18 3 times. So my final answer is a 2, and I have a y to the 4th left in the numerator over 3. Okay? Let's try the check your understanding. This is a 31.25. Okay, so number 15, we're going to simplify 3yz squared times 5y squared z. So start with the numbers. 3 times 5 we know is 15. Okay, and y, there's only a y there, so it's y to the 1st times y squared. So 1 plus 2 is 3, so that's y to the 3rd. And z squared times z to the 1st, so 2 plus 1 is 3, so z to the 3rd. So 15 y cubed, z cubed. And number 16, okay. So number 16, we have 21 f squared g to the 7/4 over 7 f g to the 3/4. Okay, the fraction one is going to be a little tricky, but it's not going to be bad, I promise. All right, so first of all, let's start with the numbers. 21 over 7. Well, 7 goes into 21 completely 3 times. So the 7's gone. We have an f in the denominator and f squared in the numerator. So this f in the denominator will cancel with 1 from the numerator, leaving me with an f left. Okay, so I'm going to start writing this down. I have a 3. I have an f. And let's look at the g's. Remember, when we are dividing, because that's what the fraction bar means, we are subtracting the exponents. So we have the like base of g, and 7/4 minus 3/4. Well, 7 minus 3 is 4. So that leaves me with 4/4. Well, 4 divided by 4 is 1, so that's just a g. So it's 3fg. Okay. So, and I'll stop right there. So your homework is not going to be this lesson practice. It's going to be the additional practice, and the instructions for that will be on Google Classroom and the PDF for it as well. All right. Have a good one, you guys. Bye.